Today we will start to talk about properties of matter, and we will continue to talk about it through the entire year. Even before we start to talk about properties of matter, let's first define this term matter. Matter is everything, everything around us, and us included. Matter is made of atoms. A lot of pieces of matter we can see and perceive with our senses, and some of it is not exactly visible to us. For example, air. Air is a bunch of atoms of molecules of oxygen and nitrogen floating around us, but we cannot see them. Still, matter is made of atoms. So imagine that we would look at sand, we would see yellow powder. If we would zoom in closer, we would see individual grains of sand. If we would zoom in into atomic level of the sand grain, we would see atoms of silicon and oxygen connected to each other in a specific manners. Those atoms, those structures make up the grains of sand. If you think about it, you will see that we have a huge variety of different types of matter. We have liquids, solids, gases, all with different physical and chemical properties. That's amazing to see how many different types of matter we have: metals, non-metals, organic compounds, and tissues. So the very small, if you think about it, variety of elements, we have about 100 naturally occurring elements. Only 100 of them create all these types of matter. So, what determines what kind of matter we have? There are two things that are in charge. It's what kind of atoms the matter is made of, because we have different atoms, there are different kinds of atoms, and organization of those atoms in the matter, how atoms are connected and how they are packed. Here are some examples. Here is sodium chloride, table salt. It's made out of atoms of sodium and chlorine. The different type of elements such as silicon and oxygen can join together to form sand. Carbon dioxide and carbon monoxide are colorless gases that made of the same elements, carbon and oxygen. The only difference is the amount of oxygen connected to carbon. The small difference in their structure gives those compounds different chemical properties. Carbon dioxide is a greenhouse gas and as such is dangerous, of course. But carbon monoxide will kill us faster. When there are higher amounts of carbon monoxide in the air, our bodies start to mistake it for oxygen and delivers carbon monoxide to the tissues in our body, which can be deadly. Glucose and fructose do not present immediate threat. But I want you to see those compounds because they have identical molecular formula, C6H12O6, same number of carbon, same number of hydrogen, of oxygen, connected at a different structure, as that difference in the structure gives those compounds different chemical properties. So, at the end of the day, two things define what kind of matter we have. They are atoms that make up the matter and how those atoms are connected. Now we are ready to talk about properties. Properties are the set of characteristics that describe and identifies matter. For example, about water I can say that at room temperature it is a colorless liquid that does not support combustion. I described physical and chemical properties of water. Now let's talk about those big categories. Properties can be categorized as physical properties and chemical properties. Physical properties, the properties that can be measured or evaluated without changing composition of the matter, meaning that we do not need to go inside of the molecule and break its chemical bonds to evaluate them. For example, we can just look at it to identify its color, or we can put it on a scale to identify its mass, or touch it to figure out its texture, density, temperature, softness, boiling point, freezing point, and solubility are all examples of physical properties of matter. Now, chemical properties. Chemical properties are characteristics that describe how a substance interacts or fails to interact with other substances. So, for example, description of oxygen as a substance that supports combustion is a chemical property of oxygen because it tells us that in the chemical reaction of combustion burning, oxygen plays an important role. Carbon dioxide does not support combustion, and this is once again a chemical property of carbon dioxide, that compound is not playing an important role in the chemical reaction of combustion. Iron rusts in moist air. Well, rusting is a chemical process of iron reacting with the water and oxygen in the air, creating a new compound, iron oxide, which is that dusty orange powder that we know as rust. Aluminum does not does not rust. It is a description of chemical property of aluminum that is not very reactive, and it does not react with the oxygen and moist in the air, and thus does not rust. Alcohol burns in the air. Once again, chemical property of the alcohol that it supports burning as a chemical reaction, especially in the presence of the air. In chemistry, we will mention two big categories of changes that we will observe: chemical changes and physical changes. Let's start with physical change. It is a change of form, but not of composition, not of structure. Appearance might be different, but no new substance is formed in the process. So, for example, if we take a cube of ice and it will melt, it will be now present as a pool of water. Nothing really changed to the water itself. The molecule of H2O is still the molecule of H2O. The molecules are just reorganized. They are in a different structural appearance, but the molecule itself on a structural level remain the same. So melting as well as boiling or freezing, they are physical changes. Grinding something into a powder also an example of physical change. While we can grind something into the powder, we are not really affecting the inner structure of the molecules. They are remaining the same and no new compound is formed. Change of color, if it's not accompanying the change of composition, it is also an example of physical change. Here we have structural differences between solid, liquid, and gaseous water. In all of them, we have molecules of H2O, oxygen connected to two hydrogens. Those molecules are organized differently, but otherwise, structurally, those molecules are identical. So, whether ice is melting and becoming a liquid, whether liquid is boiling and becoming gas, or gas is condensating into liquid, or liquid is freezing into solid, all of these are physical changes. They are not represent chemical change. It's just a change of appearance, not a change in structure. Chemical change is all about production of a new form of matter with the new composition and the new properties. So, for example, when we burn paper, the result of burning is reorganization of atoms into new compounds in carbon dioxide and water, and it's all totally different from what the paper used to be. Souring of the milk, remember that sting that comes out of the bad milk? It's a result of result of some bacteria working on the molecules of milk, decomposing it and turning it into new compound, some gas with the strong odor that we can feel. The rusting of iron is example of chemical change because we have iron reacting with the oxygen and creating this new compound that has totally different properties and totally different composition. Atoms were reorganized in chemical reaction. A new compound has new properties. A new compound has a new composition. So chemical change occurs when we have new compounds formed as a result of it.